Okay, last video for day 5. The first one is pretty straightforward, guys. We have a figure and it's reflected across a line. And we need to know which figure would be that transformation. So imagine I have a line of reflection here, something like this. Okay. If I reflect this, I just used an R over this line, then it's going to look like that. So you simply just need to be able to do the reflection. Be creative, trace. You can actually trace, use a piece of paper, trace the figure, and then physically flip it so that you can see what it will look like. You could even take the paper and flip it and hold it up to the window and see what it will look like, okay? Question 14 is pretty involved. They want us to draw a line on a graph that basically is going to be in between two other lines. Well, in order to draw our line, we have to know some details. For a function a, this would be function a here, we need to know, I'm just going to write a right here, and this would be function b, and I left some spaces I'll show you in a minute. The first thing we want to do is figure out the rates, okay? Change in y is 8, change in x is 4, so 8 over 4 equals 2 over 1. So for every 1 that this moves, it's going to move 2 over here. So I know that my m equals 2. Now to find the b, remember, if I can figure out where 0 is and what this is, so if as this moves back 1, so to 2, this will move back 2, so that would be at 10. If we move back another 1, this would be 8. And if we move back another 1, this would be 6. So not only do I know that the rate is 2, but b is 6. So an equation for this one would be y equals 2x plus 6. So that's function a. Function b, if we look at our difference here, we get a difference of 12. Okay, and over here we have a difference of 3. Okay, and so 12 over 3 is 4, so m equals 4. Now that means as this moves 4, this will move 1. So we can actually, if we move 1 up, that gets us to 0, and if we move 4 up, we get 2.5. So we would have the point 0, 2.5, just as 0, 6 was our y-intercept. This would be our y-intercept. So b equals 2.5. So their equation would be y equals 4x plus 2.5. Okay, so we need to have a line on our graph that has a y-intercept between these two y-intercepts, right? So it needs to be between 6 and between 2.5, and it has have to have a rate that's between this one and this one. All right, well, if this is 2 and this 4, I would suggest a rate that goes in between those would be pretty obvious, right? Would be 3x, right? And then we would just have to pick a spot for our y-intercept to be somewhere between 6 and 2.5, so maybe just something like 4 or 5. All right, so if this is going to be our equation of function c, now we have to graph that. And remember how we graph? Just substitute. All right, well, we know where 4 is, all right? Actually, we don't even have to substitute. We put our point at 4 on the y-axis, because that would be our y-intercept, and then travel up 3 and over 1 to get our next point, and then draw the line. So while it's pretty complicated, it looks complicated, lots of parts. Remember, find the y-intercept and rate for function A, find the y-intercept and rate for function B. That'll let you know what your rate and y-intercept has to be for function C. And then plot the y-intercept, rise over run to get the next point, draw the line. All right, good job. We're through 5 days of working on these packets, so we're more than halfway there. Keep it up. Excellent work.